Hello and welcome to the Harmonizing Hamsters workshop. Today we will be making cartoon hamsters sing harmonies. In this workshop, you all will be the audio department for the Harmonizing Hamsters cartoon. During this workshop, you will have fun with audio engineering. You will make LabVIEW code, gain understanding on how music relates to physics, how notes relate to frequency, and how signal processing relates to math. There are many fun career possibilities in signal processing technology, and music can help you get there. Just look at all the different career paths music can take you to. Now let's get started with understanding the mathematical basics. This is a sinusoidal wave. The sinusoidal is like a pure violin note in music. Using the equation, LabVIEW calculates a sinusoidal point by point. This is what you see when the program is first run. The variables in the equation are A for amplitude, F for frequency, and T for time. We will vary the amplitude and the frequency to understand what that means to music. Now we will walk through how to create and code a LabVIEW program that makes a sinusoidal waveform. Pay close attention and try to follow along on your computer. Display the block diagram by clicking on Window and selecting Show Block Diagram. Creating a LabVIEW program that makes a sinusoidal waveform. First thing to note is the broken arrow under the word Edit. This means there is a problem in the program. Click on the arrow and the error will be explained. In our case, here it says block diagram for loop is not wired. Note, the loops to run needs to be connected to N on the for loop. A for loop is a program structure that will execute repeatedly with the index I increasing by 1 each time until the loop count is matched. Now we will fix the for loop error. To do this, we must use the tool palette by clicking on View and selecting Tools Palette. You may move the Tools Palette to a convenient place by click and drag. Now, select the Wire tool and wire the loops to run to N in the for loop. Once connected, the broken arrow turns solid, indicating the program will run. Save the program. Even though the program will run, there are 3 other problems to fix in order to get the results we want. First, in the for loop, wire the I to the array block. This will put each calculation of the sign in the array block in order. Second, wire the output of the array block to the R sinusoidal waveform icon. This will send the array block data to the display for us to see. Save and run the program. It should immediately plot our sinusoidal waveform. To see the program do each calculation, we can slow down the program. To do this, click on the Tools palette as shown in the diagram, and then double-click on the 0 to the left of the little watch in the for loop. Type in 50. This will cause the program to pause a half second between each calculation so we can see the progress. Save and run the program. You have programmed in LabVIEW. Congratulations! Now on to the harmony. What is a harmonic? By far, the greatest part of the world's music is non-harmonic. A harmonic is a signal or wave whose frequency is an integral, whole number, multiple of the frequency of some reference signal or wave. The next few pictures will show the work of creating a harmonic wave 2 to wave 1. The formula for a sinusoidal is shown. The formula will calculate waveform 1 point by point slowly so you can see it happen. In the formula, the program will increase t, time, for each new point to draw our waveform 1. You should think of the waveform as a pure note from a violin, for example. We will create waveform 1 by selecting the amplitude and frequency using the sliders. Also notice that waveform 1 plus 2 is shown. This is the sum of our waveforms. Here you see we have set the amplitude to 4 and the frequency to 2, and then ran the program. Here shows waveform 2 as active. The objective is to create waveform 2 to be a harmony of waveform 1 by one of the following. 1. Its frequency must be twice the fundamental note frequency. 2. The ratio of 2 to 3 yields the fifth. Or 3. The ratio 3 to 4 yields the fourth. This is the block diagram that was used to create the sinusoidal waveforms 1 and 2 shown in the last 3 pictures. Now onto the signal recording and analysis program. We will follow the listed instructions to operate the program. You will see the time waveform of your song first. This shows the waveform's varying amplitude. After you are okay with your song, watch the frequency display of your song over time. The units of frequency is cycles per second, or hertz. Frequency is equivalent to the note you sing. For example, the note middle C on the piano is about 261 hertz. You can move the cursor, the red line, to measure the frequency. Once your song is just right, you will be ready to have your hamster sing your song. Just watch our example. Now let's make some hamsters harmonize, and then you may upload your videos to YouTube. Thank you.